There was a period of time around the time when I started being a maintainer and like a bit before it when I was writing a lot of code. Just because, again, I think it aligned very well with what my company needed at the time. Now, like over the time, I've just gotten like review ownership over more and more code and being brought into more and more like, hey, you know how this works, so can you chime in? So I've definitely like drifted way more towards the side of just communication. It's always nice to get some code written every now and then, but there's so much other stuff that happens that I always have to be careful about making myself the blocker for code landing.
Hello and welcome to Committing to Cloud Native, the podcast where we talk about the interface between open source and cloud native. We're super excited about our guest today. Can't wait to introduce him. Our panelists today are Justin Dorfman and Tzury Yochay, and they're going to have an awesome conversation. I really enjoyed listening to it, and I really hope you enjoy this conversation.
Today we got Snow Pettersen joining us from Lyft. He's on the Envoy Proxy project as well. Senior Maintainer. Tzury, you're here. What's up? I thought you almost had COVID, but you're good.
Hey, JD. Hey, Snow. How are you guys? I'm all good. I'm fine. Thank God.
Okay. Thank God. And Snow, how are you? You doing good?
I'm doing great. Yeah. Happy to be here. Thanks for having me.
Well, I really appreciate you coming back because for the audience that doesn't know the backstory, Snow was on like a month or two ago and the audio was so bad that we had to pull the plug. So we rescheduled and Snow, thank God, said yes. And that's where we're at. And we just want to basically go over what we talked about, but this time with a new recording platform and new equipment. So thank you again, Snow, for really taking the time to do that.
Yeah, no problem at all.
So cloud native, you've done it at Square, you've done it at Netflix, you've done it at Lyft. How has it changed over the years?
It's definitely matured a lot. I think a lot of the stuff we were doing early on at Square, particularly in like the Envoy spaces, which is how I ended up in this whole space. It was rough around the edges and it took quite a while to ramp up on things and things didn't always work the way you wanted. And I think now things have definitely matured. I guess it's been like 4 or 5 years at this point. Yeah. So more problems are solved. Things are easier to do, but still a lot of challenges.
What's a major challenge that you've recently experienced, whether it's at Lyft or just maintaining the project?
I think one of the interesting, in the cloud native space, there's been this push towards like a sidecar approach where a lot of systems are relying more and more on these like open source projects that run next to their services in Kubernetes and other systems as well. And this has been like a trend in cloud native where more and more problems have been solved via sidecars, which have like caused like a bunch of new problems around like management of these sidecars. And I think a lot of people who jumped on the sidecar bandwagon early on are now running into issues with managing all of these sidecars, with companies having 5, 10, 15 sidecars running in their pods, resulting in a whole set of new difficulties that people didn't realize would be this bad when they were preaching about the value of sidecars.
Is it like a performance issue or is it more of a security? Like what's the biggest headache that you're seeing with people using Envoy and sidecar loading?
It's a release and rollout problem. That's a huge one where it's tricky to have a good release policy for sidecars because you're kind of torn between two sides. One, which you want to get new code out quickly and safely, but it's hard to do quickly if you have to roll your entire fleet. And it's also hard to do this safely because you can try to roll your entire fleet. What kind of stats are you monitoring? What kind of like systems you have in place to make sure that things don't go wrong? And and just the idea of having like a gradual rollout of sidecars can be very tricky because you end up having to often build your own systems if you want something more granular than like per Kubernetes cluster, for example. Doing it per cluster, it's probably not too bad because you can just kind of do them one at a time, but taking down an entire cluster can be pretty bad as well, depending on your setup. Not everybody runs with a bunch of redundant clusters. And then you have this problem of like, once you start building automation for like rolling the fleet to update a sidecar, if you have a lot of sidecars that need constant updating, because you not only do you have like the open source readily available sidecars, but you're also building your own internal sidecars, you end up having to roll your fleet quite a lot, and it just creates a lot of churn. And each one of these can cause a lot of issues. Sometimes you bundle multiple sidecar updates into the same update, and then it gets very complicated because the person doing the actual rollout might not have any context around the sidecars being updated. And then the other way of doing it, where you don't roll the fleet, you put the onus on service owners to manage it. Whenever they update, they get a brand new set of sidecars. Has its own set of problems where like, oh, you updated your app, you have 7 new sidecars, something's wrong. What do you do?
That's defeating the purpose of the whole microservices architecture. Microservices is supposed to make it easier, and then this is just like monolith all over again, kind of.
That's a nice analogy because you're going back to like a more monolithic setup in a way, but the app owner doesn't really know because they're just looking at their own code and they're like, oh, my code is 500 lines of code. This is barely anything. So I'm just going to deploy this rapidly because it's such a tiny amount. But if you're then also factoring in the tens and thousands of lines of code you're deploying every time a sidecar upgrade goes out, things become tricky, and like it's harder to move at the same velocity that you would have expected given how small your supposed microservice is.
Right. Tzury, thoughts?
I think we have the perfect candidate that should answer the following question. How would you explain Envoy to a new, I wouldn't even say newcomers, somebody who knows nothing about Envoy? He hears the name, he, she, they hear the name, and they want to know what is Envoy. But they got no connection to the internet. They cannot type it in Google and get the answer. What would you say to them on a cocktail party Saturday afternoon? How would you explain to them Envoy?
Usually what I do, if I'm talking to somebody who might not even be familiar with microservice and distributed systems, is kind of tell the story of like how you end up here, which is once upon a time, there was a bunch of mainframes and everything ran on like one machine and things were easy. If you wanted to have different subsystems call each other, you just call the function, or it's just all in there. It's easy. And then to scale out, you ended up building this microservice world where you have all these different components talking to each other. And then you had to teach each of these components how to talk to each other. And also then became difficult because you had a lot of different components wanting to talk to each other. And they all had to like understand how to talk to each other. And so Envoy, in the capacity of a service mesh, we can be used in other ways as well, but as a service mesh, which I think is how most people use it, it serves the role of centralizing how these services talk to each other into a single process that can run alongside all of the applications, allowing them to communicate with each other. And this is like the very basic of what it does, but where its real attractiveness came was from like its ability for dynamic reconfiguration, which provided like a consistent way for people to interact with it. Many people have done similar things with things that relied on very like laborious ways of updating the config or complicated config management systems. So the big thing that Envoy brought in to make this problem more tractable was all of its APIs, its XDS mechanism that allows for a management server to push all of the configuration that it might need and update without restarting and in a very efficient manner and react to changes really quickly. And in addition to this, scale really well, have a relatively low performance overhead, non-zero, but it's fairly low, and also be able to scale up to very large use cases.
So when Envoy gets an update of the configuration from XDS server, whatever that might be, how does it gracefully switch to the new set of configuration while processing? And by the way, what is the Envoy scalability on a single machine? I would say a single core, to your knowledge.
So in terms of concurrency, that's an interesting one because the way that we suggest that we run it is that, and this will also come into play in explaining how this config update works, where Envoy will generally run if you want to run on a single machine, you run one workers thread per core. And and there's very little cross-thread interactions. There's some, but for the data path where you're handling requests and proxying them, a single worker thread accepts it and handles it for its entire lifetime. And Envoy will basically, each thread, I think, is able to handle it's a really hard question to handle the scalability because it depends heavily on which features you're using. TLS versus TLS makes a huge difference, for example. I recall in the past there being talks about I think 20 or 30,000 RPS synthetic benchmarks being run, but that's obviously very you strip down everything and you run it with nothing.
So it wasn't HTTP 2, it was HTTP 1, for example, with no HTTPS, no TLS.
Yeah, with no modification of the payload, no access control, no nothing. It's just, and so which is not how people would use it. So it becomes, the value of such a benchmark becomes questionable because there's this whole other set of features that I might use.
Well, that's still an impressive number.
So going back to how the config update works is it's generally, there's the static config that it comes up with, they call it bootstrap config, which is required at runtime. This has to be, you need to do a process restart in order to change this. But the typical way you would just define this static config is that you would basically say, get all of my actual config from the management server. And then the management server is responsible, will receive a request from the client requesting, hey, I need to know about all of my configuration. And so the server will respond to all of these, and the anomaly comes up with an internal object instantiated per resource you want. So these are listeners, which define which port, protocol, and transport socket, TLS, whatnot configuration for each listener. Clusters, how to communicate with other systems, endpoints, the IP addresses associated with these clusters. And then as any new config comes in, this gets handled on the main thread, which is used exclusively for this control plane interaction. And it gets processed, it gets validated, and then it gets posted to all of the worker threads, telling it to update its thread local version of this data. And there's another mechanism where generally config is also snapped to a stream or a request. So if you get a request and while you're processing the request, you get a config update, it will still act on the old configuration just to make sure you have that each request has a consistent view of what the configuration looks like.
So in terms of the Envoy architecture, there's something that when you dive in a little, you find it quite quickly. The beauty of having a stripped down core, barebone, I would say, minimal core of Envoy, while almost anything you want to implement and do, things of which you consider obvious and ground level, are pretty much implemented as filters or as extensions. And I believe that was done by choice at the time. Can you elaborate a bit about this architecture?
So if we just start off with the filters. For processing an HTTP request, you can define a list of filters, which is each filter will process the incoming request and the outgoing response and gives you a chance to modify the request. I think early on, this predates me, but I assume it was natural to just implement the routing mechanism as one of these, because what is the actual routing mechanism? Well, it's a thing that accepts the request and it generates a response. So this fits neatly into the filter mechanism. And I think in constructing this extension mechanism, it was an early choice to make it very generic so that the way extensions are done can be reused for basically anything. Basically, you have some C+ API that you can implement and you register a factory that accepts a protobuf that defines it. And this very generic extension mechanism means that you can do basically anything. It's very easy to make anything an extension point. And so a lot of things were quickly extensionified, where you'd take something that was previously not, for example, TLS used to be baked in, but in order to better support other ways of transforming the data on that level, it was abstracted into a transport socket extension, so that now TLS is just an extension. And this just opens up for so many other extensions to be built that sits in fits in the same spot in the stack as TLS. So this is definitely a intentional choice, and has allowed us to do stuff like have different security postures for different extensions. We can say that we have built in, say, 50 different filters. Only 10 of them are robust to trusted downstreams or upstreams and whatnot, which allows us to better evaluate. We can tell people, we can guarantee that this has been vetted via fuzzing and via production testing. We expect this to be secure. Others, newer extensions generally, will be flagged as we don't know or have a less robust one, which means that if we then get issues coming in saying that, oh, I found a bug, if this and this happens, we can crash the process. If it falls into one of our like less trusted extensions, we say, well, that's okay, we'll just fix it. And while the other ones will go through like a security release, file a CVE for it, because we've already made the promise that these things are secure. And so we have to go through the right process to make sure that we disclose it in a responsible manner.
Does this have anything to do with the new contrib folder proposal, or is it completely different?
So the contrib folder is basically a proposed new way of structuring extensions where, in addition to having basically core and extensions, instead we'd have core extensions and contrib. And contrib being like a new collection of extensions that are held to a like not the same bar as core extensions. And this is to address in terms of like coverage, making sure that it's been signed up by like a core maintainer and whatnot. The idea being that there's a lot of very useful extensions that people are proposing, but some of them they show up with like a 5,000 like line PR and they're like, hey, I made this extension. It's super useful. We've been using it in production. But in order for us to get it into a state where we'd be okay putting it to core, it just takes so much time and effort. So unless we have somebody willing to do that work, it just sits there. And so contrib is a way for us to say, yes, we'd happily take it. We're going to put it into contrib, which means that we'll do some like due diligence, make sure it looks sane, and then we'll probably put it in there.
I mean, yeah, that's definitely going to help. It's kind of like the WordPress model where you have this like plugin directory, and I could just see this taking Envoy probably to the next level if this proposal gets accepted and then built upon, because it's got to be very discouraging for developers coming and sending a pull request and then getting it declined. And then it's not like you want to do that. It's just got to find the time, and there's other stakeholders that are going to be affected by this inclusion in the core. So I think this is probably the best way to kind of combat this issue that you're having.
I think it's going to help a lot. I think at the moment, there's so many different paths towards like a very extensible platform. The WebAssembly work that is being done, it's still a bit too immature, I think, for a lot of people to be willing to use it, but it's getting there. There's also a proposal around adding better support for Seago. So you could write a filter that like calls in through a Seago API into like a real Go binary as opposed to like a Go WebAssembly extension. There's a lot of interest in making the platform more extensible. And so I think contrib will help quite a bit when it comes to like the space of like native extensions. But there's other things which I think will help a lot as well, which is like WebAssembly in particular. I think it has a lot of potential. The Seago one is also very interesting.
I'm looking at a GitHub Envoy project, and I see over 700 developers contributing code and patching. And so how do you guys maintain the time utilization all this takes, the efforts and the time to navigate between the community, users, developers? And I believe even without that, you would have your roadmap and your to-do list already set out for upcoming years, right? I mean, Envoy has its own roadmap. I mean, let me put it this way. When someone comes to a live project, and Envoy is definitely one of those who, right now, super cool, super popular, taking over cloud vendors. We had the projected Yochay from Google last week, and we just talked about how Envoy was actually embedded within Google Cloud products. And we know Azure and Microsoft Azure, AWS simply do the same. So Envoy has its own roadmap, and even without our community involvement, it will have its own tasks, projects, priorities, features upcoming, and so on. Now, we come in with our own ideas, some of them matching what is already on the roadmap, some really cool ideas, some of them less cool, probably. How do you guys prioritize, manage, maintain these, and find the balance between all of this? How many people within the community, if I say, how many of you guys are actually maintaining and monitoring and moderating all this process?
We have maybe 10 or 12, something around that, maintainers. We have a weekly on-call rotation where every week there's a new maintainer who's on call who will be responsible for triaging issues and PRs, assigning them to a reviewer. And I think that works reasonably well. It's always tricky because sometimes there's very hard questions asked and we don't know the answer and it requires some investigation time. But a lot of that, it's about finding the right person to tag on the issues and kind of understanding who the domain expert on the different parts are and just knowing who might have opinions on things. In terms of prioritizing the work, that's always tricky because, as you can imagine, most people working on it generally have their plates full. Smaller things can often be, you kind of just get it done. Like if somebody asks for like a very small addition and I know exactly how to do it, I could very easily just do it right there and then and just put up a PR. But a lot of things are much larger. And then a lot of the time we're kind of reliant on somebody from the community being able to step up and take ownership over landing it, or somebody from like a maintainer or whatnot that has some company internal motivation for getting it done. That tends to be very helpful where, for example, Google did a lot of work in order to reduce the footprint of stats because they had a lot of like issues internally, as I understand it, with certain large deployments hitting memory issues. And so for them, it was easy to just kind of show up one day and say, hey, we're going to rework how the stats subsystem work in order to improve things. And a lot of the work, we're seeing a lot of work now coming from Google as well on implementing Quick. So, and because that's in their interest, if somebody shows up and they have a feature request around Quick where they might want to, whatever it is, something that might not be on the immediate roadmap, given that there's already interest in, there's a lot of people in the community who are working on it, it's a lot easier to prioritize that kind of work. But there's definitely a lot of like requests around stuff that none of the maintainers have a strong desire to work on, either via their company or personal, that you're basically fully reliant on the reporter or somebody else stepping up and saying like, yeah, I'd like to implement this.
So I hate to like go back a little, but I'm really interested in contrib. The reason I found it was I subscribed to the Envoy mailing list and I saw the Google Doc they submitted, and you see excitement in the Google Doc. So I believe that this will just be a new chapter for Envoy, because we did have Anna Brennenberg on, and she's very pro Envoy and also running it very lean without too many extensions. So this whole new way of using extensions that might not be, Google would never install into their infrastructure, but many others might. What do you anticipate on extensions that will be coming out that can't make it to core? Like, what is it that people want that they can't get right now?
Small extensions have typically been like a lot easier to get in. So if somebody wants an extension that like does like a very small modification and whatnot, as long as that is somewhat generic, that's been okay. So I think the bigger thing will be like larger filters and extensions. So a great example here, I think, are like protocol parsers that will like generate stats, and both like stat generating ones and also like ones that can do routing. So like various like protocols that aren't currently supported. I said this because I've reviewed some of the PRs to add support for other protocols. I helped land the like support for Zookeeper stats generation. And that's like a 3,000-4,000 line PR which is very hard to get in because it definitely requires like aligning interests between maintainers and contributors. Without requiring this maintainer sponsorship, I think it will be a lot easier for people to add in support for like parsing data of various other protocols. So I think that's probably a big one, because I've definitely seen a lot of issues with people asking about support for some protocols that I'd never heard about, stuff in like telecom and like other things where they wanted to be able to do like have some kind of like understanding of that protocol. And without a sponsor, that's been really hard to get in.
Are you talking like layer 4 protocols or higher ones?
I think they're all higher. Yeah, I think they run on top of TCP. I don't think the room for extensions in implementing layer 4 protocols is a bit tricky, I think, just because where the extension layers lie today. But I'm sure there are people who will be interested in doing that too.
They can basically implement that, say, as a TCP filter, right?
Yeah, exactly.
On top of the TCP, yeah.
Like that's how the Zookeeper filter is implemented. It's a TCP networks filter that sits before the TCP proxy. So all it does is it inspects the byte as it flows through the proxy and parses the protocol, which then allows it to generate stats based on which commands are used, which I think is mainly around which commands are used, before it then gets passed to the TCP proxy, which just does like a standard TCP proxy of the data.
And none of this is considered sidecar loading. This is just...
Yeah, you're beefing up your sidecar. But
okay.
Yeah.
I like that.
What was I would say, the most obscure, unexpected use of Envoy in production that you came across? That you say, oh, we never imagined that people will use Envoy that way or for this purpose. And you just, oh, that's awesome. Look to people's imagination.
I think there's some cases I've heard of them like running it inside of like vehicles. I don't think it's fully autonomous, but like as part of some system. I forget the details, but I definitely heard cases of being like distributed systems being operated within some kind of vehicles. I forget the details. I'm sorry. I'm afraid.
Oh, good. Like autonomous.
Like in the car.
Yeah. But if you really think about it, it's also not that weird, because I'm sure they used to have like some microservices running and they need to connect them somehow. So they're probably running Kubernetes too. I don't know.
Like a Raspberry Pi stack.
Why would you have microservices inside your Tesla? How many services are running within Tesla, for example?
It's an interesting one, because I'm sure at some point you get the same problems in that space too, where like you want like one team to work on this component and they want to be able to like have like a nice contract so that they can make changes to their system without having to affect the other ones. So then, yeah, now you're talking about like API contracts between components, and you're not too far away from the microservice architecture. Like maybe you're not going over the internet, but
the car is a portable data center, or I would say mini data center, right? Interesting. So if I'm asking you, like, over the years, your roles in Envoy, how much of your time has to do with writing new code versus reviewing others versus answering emails and file or responding to issues on GitHub, which is equivalent to emails, and communication in general?
There was a period of time around the time when I started being a maintainer, and like a bit before it, when I was writing a lot of code, just because, again, I think it aligned very well with what my company needed at the time. Now, like over the time, I've just gotten like review ownership over more and more code, and being brought into more and more like, hey, you know how this works, so can you chime in? So I've definitely like drifted way more towards the side of just communication. It's always nice to get some code written every now and then, but there's so much other stuff that happens that I always have to be careful about making myself the blocker for code landing.
Well, looking at your GitHub profile, 72% of your time is on code review, 12% on commits, and 16% on pull requests. So you're doing quite a review.
Yeah. No, I think I just had my like 6-month like review at work, and I pulled my stats, and I think I had like 300 or 400 reviews, which is like number of times I like hit submit review, whatever. Yeah, over 6 months. So it's quite a bit.
What are the golden rules for code review? that you would share with the public? When you review a code, what are the do's and the don'ts?
One really important part is making sure that assume that the person that wrote the code has good intentions and that they're doing their best. So be respectful in that way and make sure that you're not, if they do something wrong, tell them gently. There's no reason to be mean. So tell them gently and like explain what's happening and ask questions and don't be too arrogant. I think I see a trend somewhere where people say like, you see comments like, well, this doesn't make any sense at all. Why are you doing it like this? And sometimes they're wrong, right? Because sometimes it's because the thing that they did is perfectly reasonable. They just like miss the context because even if you're the supposed expert, you doesn't mean everything. So I'll do much more of a cautious approach where if there's something that doesn't make sense to me, I'll ask them why this was done and try to understand it and kind of present it like that. And I think having that kind of like showing that kind of respect for the people who wrote the code is very helpful because it helps the PR you're working on to proceed smoothly, but it also means that they're more likely to come back because they've had a good experience. So I think just creating like a very inclusive environment. Let's see, there's a running thing in Envoy PR reviews where the maintainers in like 99% of the time always like includes the word thanks when they approve a PR. Always gotta show your appreciation.
No, it goes a long way. It really does because it's really hard to get in someone's head on the other side and just be like, are they mad at me? Are they annoyed? So yeah, that definitely goes a long way.
I thought this was super helpful, like when I was like ramping up on the project as well, and also seeing like sometimes a PR drags on for a long time, and also including like hey, thanks for iterating on this. This will be great. Just making sure that people are encouraged to keep working on it, because yeah, like you said, it's hard to communicate your own like state of mind through GitHub issues or PRs. So like including like a very clear like, hey, no, I'm very happy that you're doing this work. I think it's very helpful. No,
definitely. I mean, like the emoticons, those are cool, but sometimes people just like to do a thumbs down and that's just like a burn. But I think overall, it definitely goes a long way. No doubt about it. It's very important that people do communicate their gratitude. And it would actually be a really interesting college thesis to see which projects, what the language is like, thanks versus not thanks. How healthy is the project in terms of adoption and this and that? I don't know. If we have a listener that wants to do that, that'd be really interesting. And I'm sure Snow would help you out. Anyway, it was so great having you on. We're going to do a little after show after, but before we go on to that next phase, how can people find you online? Is it Twitter? Is it GitHub? Where can people find Snow?
I'm on Twitter. I think one of my Snow EPs, and my GitHub is SnowP. There should be some links there to find me as well.
Yeah, we'll be in the show notes for sure. And is there anyone in the Envoy community, specifically in the Envoy community, that you'd like to give a shout out to so they can be like, oh my God, I was mentioned on a podcast?
The entire Envoy community. Thank you. Thank you for everything.
Awesome.
Listeners, I hope you enjoyed this one. Do tune in next time. We're really excited about our lineup of guests. We have a super exciting guest next week. As well, check out the show notes for this podcast at podcast.curiefense.io. That's CURIEFENSE. Podcast.curiefense.io for the Commuting to Cloud Native podcast. Thanks again for listening. Tune in next week. Catch you later.